Hello, online people, can you hear me? If you can, please type yes. Oh, thank you, Samantha. Hello, hello, can you hear me? Yes. So your exams is coming soon. How's your preparation going? Are you studying hard or no? So after this, there will be a final exam as well, right? Online students, if you have any question, please type your question and I will get back to you all. So let's begin. The first question is from page number 37, chapter 22. This all is about enols and enolates. So the first is draw the enol tautomer of the following compounds. So first of all, let's understand what is the difference between enol and enolates. So enol, from the word, you can understand it is en means a carbon-carbon double bond and ol, all means OH. Then enolates, en means C double bond C, and then olates would be O minus. It is not a protonated version, it is an anion, okay? That's the difference. So here in this question, you will be given so many questions or a few questions in your exam, perhaps like this. So you need to understand whether they have written enol or enolate. So as here it is saying enol tautomer. So it means that it will be C double bond C with OH. So let's start with here benzyl COCH3. So this is what? This is a CH3, right? And here there is no hydrogen, right, to the phenyl. So whenever you have tautomerization, you will form with CH2. So why? So how it works is that the hydrogen from here will be removed and this will go. Okay. So the next is this one. So it can be either this side or that side. It can form either ways. And it's symmetrical, so that should be okay. The next is this, where there is just one hydrogen here, so we cannot form a double bond to this side. So we have to form a double bond to the other side. So it would be OH and this is hydrogen. Okay. The next is this, and you can see here that there is oxygen and there is OH. And we cannot call, so if you make a double bond here, it cannot be an enolate. So in order to be an enolate, the double bond will be towards carbon side. As we understood that it is carbon-carbon double bond, so it needs to be a bond between carbon-carbon. Okay. Same applies to this ester, where there is carbon only to the other side. You cannot form a bond, double bond here. So it would be, and for this side, it's really interesting because this one, many students, they forget that there is a hydrogen here. So you always remember that there is a hydrogen. Like you always count bonds, like how many bonds this has, 1, 2, 3. So it must be that there is one extra hydrogen. So it would form enolate, enol here. Okay. Let's go to next question. So here they say some compounds can form more than one enol tautomer. Draw all the possible enol tautomers for the following compounds. So these structures, they may have one or more than one. So they are saying enol. So we will draw of enol, okay? So here you can see that there is carbon this side, there is carbon that side. So there are two kinds of enols which is expected. So one will be from this side and the other will be from the other side. Okay. For this question, you can see, let's discuss this afterwards. I'll talk about this afterwards. Let's go through this first. So for here, there are two carbonyl groups. So how the situation would be? This phenyl, it means that there is a benzyl and there is this carbonyl. So there is no hydrogen here. So you cannot have enol at that site. So the site where you can have enol is only this site, right? So here you would write PHCOOH like this one. The other would be to the other side where it is PHCOOH O ether, right? So these would be two possible. You cannot have both at the same time. If you have both at the same time, well, let me see. You can, but it's just both will be hydrogen, you know. So this can be possible, okay? But both will be diol at that time. So these are three tautomers of this structure, the possible tautomers. So regarding this is a very interesting compound. As you can see here, there is a carbonyl and it's not symmetric in nature. So there is a metal group at one side, the other side is without a substitution. So the possible structure for enols, it can be OH and one would be here and the other would be towards this side. Okay. So what is the difference here? In one structure, there is a double bond towards a more substituted carbon, and the other, there is a double bond at the less substituted carbon. So this is the less substituted carbon. This is a more substituted carbon, right? So how you can differentiate enol based upon this? So there is one a kinetic enol and the other is thermodynamic enol. Okay, have you guys studied about this? Kinetic, thermodynamic. Okay, so this is the example of it. And here you can understand that this is a sterically hindered. So let me write it on a page. Hello, online students. Can you hear me now? Please type yes. Okay, so everyone can hear me. Okay. So anyone can tell me from which question did you guys miss so I can tell you? I can go back and repeat that question. You were just explaining this one when you cut out. Oh, that's nice. So the kinetic and thermodynamic stuff. Okay, great. So I can, uh, okay. So I'll go back and, okay, thank you. So I'm sorry guys, you have to hear it again, but I'll tell my online students. So here the difference is this is really an interesting question and you guys need to understand what the structure is. So here in that structure, there are two products which can form. One is kinetic and one is thermodynamic. Like, so here are the structures which I have drawn. Here, this one, this carbon is less sterically hindered and this one is high sterically hindered. So whenever there is enol which is formed at this site, it means that it is a kinetically enol, controlled enol. And the other one is thermodynamically controlled. This is the sterics. So why kinetically enol? It's known as kinetically controlled because this occurs very fast. Whenever there is a graph and you see this is the activation energy, right? So the less activation energy means it occurs very fast. And a high activation energy means it needs a lot of energy to go through the reaction, to pass forward the reaction. So the kinetic is fast and it has less activation energy. The thermodynamic, the product has a very good stability and it can be determined by this graph where you see the reactant and the product is very low. So whatever is the difference between reactant and product energy, that shows what and how stable the product is. So more the gap, the more stable the compound is. So as the substitution here is methyl, even though there is another substitution, still the stability would be more and it would be still called as a thermodynamic enol. So that's what I explained. And let's move forward now to the next question, which is circle the site of the reaction favored at equilibrium. So here you need to see they have provided pKa. So here the pKa is 17 and the next is 15.7. So always the reaction occurs from strong base to weak base. Okay, that is the main basic thing. So here, where is the strong base? This is the strong base. And which compound you can say that it is a strong base? Because pKa is less compared to the other. The weak base pKa is high. So here this is less, this is more. So the reaction will move forward to this pathway, and this will be the final compound. For here, this is 9, this is 17, this is higher. The reaction will move forward to form this. Here, this is small, means this is a strong base. This would be a weak base since it's 15.5, and then the reaction would go through this side. Okay, so that's there. So coming to the next question, which is this arrow pushing mechanism, which I really love every time. So it's so interesting because, yeah, it's just interesting. So if you understand basic chemistry, you will be able to do it. And it's super, super, super simple. So I'll try to draw it here. Or you want me to draw in a page? I can do that. Or let's do it here. I think I can do it here. So whatever is there, I'm doing in red. So the first is this structure. What is it? It is an acid or acid. So when you have this H, O, O, like this is an acetic acid, right? CH3COOH, okay? So this is acetic acid, and this, our oxygen, it has 2 lone pairs of electrons, okay? So what happens is that it gets protonated, and it will form, for benzyl ring, I'm just writing phenyl because it's easy. And then you get OCH3, and this is a protonated version. And initially, oxygen was having 2 lone pairs of electrons. And now, after reacting it with hydrogen, it is just remaining with 1 lone pair of electron. And that's why it has a positive charge. Okay. And there is a removal of O minus. This is acetate anion. And this step is known as protonation. Okay. Everyone getting me? Everyone can see it, right? I can. Yes, everyone can see it clearly. Okay. So after this, what happens is that this O minus, what is this? This is a CH2 and hydrogen. We can also write it like this, right? CH2 and hydrogen, which means CH3. So this O minus, it will attack to this hydrogen, the alpha hydrogen. This is known as alpha carbon. And then this will go here, and this will go here. So by adding hydrogen to this oxygen, it makes more nucleophilic. Okay, the carbonyl groups becomes more nucleophilic, and you would get pH OH, and this will be now 2 lone pairs of electrons because the 1 bond has been reduced. And then there is the CH2 as it is. So 1 hydrogen has been plucked off from this, and it will go with acetic acid, will be removed. Okay. Guys, you need to understand arrow pushing mechanism because most of your exam, you lose point in this kinds of question. If you notice, exam 1, exam 2, you always lose point on this kind of stuff. So you understand what the basic is and what I'm saying. So after this, there is this Br2. That is the role of acid. Now next comes Br2. Br2 can be written as like this. So here, there is this oxygen lone pair would go here, and this double bond would go here. It would attack and it would come back. This will form pH. Again, this oxygen will form double bond. That's why it becomes positive here. And there is this CH2, which will react to Br. Okay. So whenever you see such structure, you need to understand that Br is forming here. So you are not going to add Br on phenyl. You will write here. Okay. After that, and then this Br minus, whatever is removed from here, it will go and it will attack here, and this will go here, and it will form HBr as a side product. Okay, and it will form this compound. And this reaction is known as acid catalyzed bromination. Any question? Any question, guys? Okay, so I think you guys are understanding. So let's move to our next part. Next question. This is a malonic ester, and we have to create a retrosynthetic path. So the first thing is, whatever is here, this means it is a starting material, and it means this is a product. So let's go. So the first step for this would be, you understand now, whenever there is retrosynthetic, you understand, okay, there is a COOH, there is a COOethyl. So it must be that this is intact. So where is the position that an attack can be? This is a position. So what group needs to be added? There is this group and there is this groups need to be added because there is already a carbon which is present. So you need to add two groups on this carbon. So the first thing is, this is an ester, malonic ester. And from that, you need to form a carboxylic group from that malonic thing. So whenever you have such reaction, always remember, this is very important. It can be even in your exam. Okay, so understand me. Whenever there is this structure with two ester group and there is one carbon which is present in between, this carbon which is present in between two esters, you see what is the product. So right now here, the product is COOH, and here this carbon would be this carbon, and you see how many substitutions are there. So right now there are two substitutions, right? So it means there is one hydrogen. Okay, if there is one hydrogen, it means that there is a double alkylation reaction. Note this down. This is super, super important. And if there are two hydrogens instead of one, there are two hydrogens, it means that it is single alkylation. This will gain you a lot of marks if you understand this. Okay, so it means there is single alkylation. So right now in our case, if there is single alkylation, it means only you need to add one reagent alkylating. For here, if there is one hydrogen, you need to add two different or two same reagents depending upon the structure. So right now you can see that there are two substituents which are very different. So you need to add two different reagents. So coming to the pathway, the first step would be adding base, sodium ethoxide or any base. So there are these two hydrogens. It will go and it will pluck off the hydrogen, which will form an enol, enolate actually, to be precise. Okay, there will be a resonance structure. These guys show resonance because most of the students have lost marks because they don't write resonance. Show such arrows. Each arrow has 1 point. Just for your future exams, each arrow consists of a 1 point, right? You see? So I moved arrow from here, this will go here, this will go here. So coming to the lone pairs, this would be 2 lone pairs of electrons. This would be 3 lone pairs of electrons. This would be 3. This would be 2. The third resonance would be a different one. We don't want to repeat the resonance. Even though they don't ask mechanism, but I still want to show you few important steps which will make your life easy during exam. Because I myself graded with one of other TA your exams, and I've seen people lose points in arrows because they don't put arrows. You can't just draw structure. Yes, you will get marks, but even the arrow has importance. We need to see how the flow of electrons is, and each arrow has a point. So you need to draw that. Okay, so these are 3 structures and each 3 has important points. So after this, let's move to next addition. The first addition, as you can see in the structure, there is a phenyl and a CH2 group. So you will draw phenyl CH2Br, that is also known as benzyl bromide. You will add it, and then what happens is that this will go and attack here, and this will go away. There is hydrogen adenine. Okay. So after this, again, as we have second alkylation, this is known as first alkylation. In the second alkylation, you will again react this with sodium ethoxide. This will go here, pluck the electron, pluck the hydrogen, I would say. Again, there are resonance, like I can show you the resonance. For the first time, for the other questions, I won't go through it, but you noted this down. This will be very helpful exercise. For this, it will go here, it will go here, and it will form the next resonance would be that this is going here, this is going here, this is going there. Those are the 3 resonance structures. Okay, but for our reaction, we need this resonance structure. So for the second alkylation, we have this compound like CH3, CH2. So we need to add something like ethyl bromide. So what happens is that when this comes, it attacks here, it goes off. Okay. And this would give you like this structure. So this is known as a second alkylation. This mechanism which I'm writing, it's super important, okay? So you understand, because based on this, there are few other questions which we are going to discuss after this. So after this, you just add H plus, heat. So what it will does, this will protonation and hydrolysis, which will form the final compound. And this has hydrogen. And this hydrogen comes from these H plus. Any questions? Online student, any question? Please text me. Text me, I'm sorry. Please send a message. Everyone noted this down? We are going to follow up with this mechanism for our next questions, okay? So that's the mechanism. Actually, the question was, what is the retrosynthetic pathway? I think I have shown you guys the mechanism, so you would be able to draw the reagent, because we have the reagent here, sodium ethoxide, and then going with this, so you can just write, okay? So the next question is with here. So this is a same kind of question, right? There is two ester, there is one carbon. This carbon has two hydrogens. Here you can see that there is carboxylic acid, but the difference is there is one hydrogen, right? So whenever a compound has hydrogen, what kind of alkylation it would be? We just discussed. Will it be double or will it be single? Online students, you want to answer whether it will be double or single alkylation. Please send message on WebEx. We just discussed now. Devin is saying it's single. If there is one hydrogen, what will be the alkylation? Will it be double or single? Yes, that's correct. Devin, it's wrong. Single alkylation. Again, note this down. If you have not written, please note this down. 2H means single. One hydrogen means double alkylation. Okay. Note this down, Devin. So coming to the next question. Here there is one hydrogen. And one hydrogen means what? One hydrogen, double alkylation. So let's see what are the substitution. Like here, there were two different substitution. But here, it's a cyclic ring, right? And this carbon, as we said before, this carbon belongs to this. So if this carbon belongs to this, how can a cyclic ring be formed, right? That is a simple thing. So it means we have to form monoalkylation and then do a ring closing mechanism, which can be considered as a double alkylation. So moving to that part, let's begin with our first thing. the same. This would be same because it's like ethoxide. So the first would be same. Doing sodium ethoxide, having all these three resonance, it is similar, just the difference starts from here. So I'm going to write from here, okay? So the previous steps we all have discussed, so I don't want to spend time going through it. Okay, and there is one hydrogen here. And this is an anion, okay? So for this, we will react with bromine because we need a compound which has 1, 2, 3, 4, right? So we'll react with there and 5. So we'll react with there and we will get something ATO, a hydrogen, okay? So this is a first alkylation step. Later, we will again add sodium ethoxide. So what it will do, it will go pluck the hydrogen, remove here, and will form what? What it will form? Anyone from the audience? It will form an anion, right? So what is the next step? The next step is there is second alkylation which will occur here. And this alkylation here, it would be like this. So always the most important thing, always remember, the arrow will flow from electron rich to the electron poor, not the other way. Okay, so anion is very electron rich. So it will move always from electron rich to electron poor. Like this, it will form. And then later, we will use H plus heat. This is a symbol of heat which I use. It's just my term. And then it will form our compound, which is, because when you heat, when you use H plus, both of these people will form COOH and COOH. But when you heat, one of the geminal carboxylic acid is going to pluck off. So it will be only one COOH which will be staying there. Okay, so this is first alkylation, second alkylation, and as we discussed, there is just one hydrogen. So there is one hydrogen. So there are two alkylations which are taking place. Okay. Any questions? So I hope everyone is understanding what I'm speaking. That's what I have understood now, because no one is asking any question. And this is really important because if you see in assignment, there are so many questions similar to like this mechanism. It means that it's really important, maybe in your exam or may not be, but you need to understand the basic, and we have understood the basic now. Draw all the resonance like we did before, like here, draw all the resonance, show all the arrows. So let's move to our next question, and which is, okay. So here it would be similar, just there is one side ester, the other side is ketone, but the thing would be similar. So to discuss it further, I can go through the whole mechanism for this. It would be each O, right? So first the reaction would be with sodium ethoxide. This would go pluck off the hydrogen. There are two hydrogens here. It will go pluck off this hydrogen. It will go back. It will go here, you know. So it means it will form an enol. Okay. Again, tautomerization. And this will form, this is O minus. It will form like here. Right. These are resonance structure for this. After this, you see the product, the structure they are asking for here, how many, so there is this ketone which is staying like that. So this carbon would be this carbon, right? So how many substitutions are there? And there is one hydrogen. There cannot be two, right? 1, 2, 3. Carbon has 4 valencies. There is one hydrogen. It means what? Pick out how many alkylation? 2. That's correct. So it would be 2 alkylation. So after this, the reagent which you would be using, because there is one CH3 which needs to be added. So we will use CH3Br or CH3 iodide, and then it would form right. After this, there is a sodium ethoxide which will go and it will form, and what it will form? Anyone wants to say? Anion, right? And again, there is a resonance, right? So how the resonance would be? It will form an enolate. These are all enolates. This is moving here, this is moving here, this is moving there. So these all are resonance structure. Okay. So after this, we need to add one more reagent. And this reagent, it has what? It has these things. So it's like 1, 2, 3. It needs to be a 3-carbon reagent with alkene. So 1, 2, 3, and the next group needs to be halogen so that it will leave off. So this negative charge will go here and this will go up. Because of halogen, this is partially positive and this partially negative. That's why it will go and attack at this position and it will give our ETO right? So when you react with H plus and heat it. This is heating. So what will happen? It will only react with this ester because ketone, it cannot react, right, with this ketone. It cannot form carboxylic acid from ketone. So it will go and attack here. This will form a carboxylic acid and which will be removed as carbon dioxide, and it will give our compound, which is this. You got it? So basically, it's very similar, okay? I'm repeating it again. It's very similar. For all these questions, maybe, may not be, it will be in your exam. For all these questions, if you keep all these questions in front of you, 1, 2, 3, you will understand that hydrogen abstraction, like hydrogen is removed, base attacks, hydrogen is removed. There is this enolate formation, enolate, which will form and undergo resonance. You draw the structures, you draw the arrows, you get the resonance. You identify how many hydrogens are there. 1, 2. Then you can understand first alkylation, second alkylation, depending upon the number of hydrogens. And after that, you understand if there is second alkylation, you do the same, repeat the steps, the second compound, and at the end, you do H plus and heat. And this will react only with esters. And this will give away carbon dioxide. So whenever there is no ester, like in this case, there was no ester here, so it didn't form COOH at this side. It only formed COOH at here. Okay? And if there are two esters, remember that one ester will go off because there are two geminal COH. So one will go off and only one will be present. That's simple thing. Coming to our next question, which also depends upon the same mechanism. That's why I was highlighting a lot. So the next thing is, yeah, CN, sorry, CN. So here, you need to form this compound, right? So here, the same thing, sodium ethoxide. It will take off hydrogen from here, and it will form NC hydrogen. Okay. So what this is known as nitride. Okay. And when you have NC, it is isonitride. So right now here, and when you see the structure here, what needs to be added? There is this hydrogen, and then there is this thing which needs to be added. Right? So when you have this, you will do addition of this methyl group, which is from methyl bromide. This will go here, this will go here. It will form, one is hydrogen, one is CH. What is the next reagent? The next reagent is this ethyl 1, 2. So you will again undergo this reaction with sodium ethoxide, which will pluck this hydrogen, form what? Anion. This anion is formed. The next step is addition of another group. As we see here, there is one hydrogen present. One hydrogen means what? 2 times alkylation. So the next alkylating reagent should be ethyl bromide. Same procedure. ethyl bromide and this CH3. After this is done, whenever there is nitrile, always remember, whenever there is nitrile and you add H3O plus, that is water, or any acid source and heat it, the nitrile is going to convert it into COOH. Okay, like ester, whenever you have ester, you add H plus or H3O plus and heat it, it's always going to form an acid, but not with ketone. Okay, so after this is done, you are going to heat it. As you heat it, this is just I showed you, but when you heat it, this is when addition of H2 plus, when you heat it, this is going to go off as carbon dioxide and it will form COOH, which is the same structure with a different representation. That online students, any question? Oh, are you which question, Samantha, you were talking about? Can you please acetoacetic ester? Okay, so I think everyone got this. Let me show her this one. Is it page number 39 question? Okay, I got it. I think it is. Let me find that answer. Acetoacetic. Yes, this is the one with acetoacetic. Well, everything is not printed. My handwriting is so big. So, if anyone has not written mechanism, I'm putting this for a minute and you can write the whole thing. Yeah, yeah, it is this question, Samantha. So how are you feeling about this course? Is it easy or is it tough? Mm-hmm. Getting there? You try? Yeah. Okay. Like this. Yeah, it's just the good thing about this semester is that it was going to finish early. So I'm super excited and super happy that we'll get a big vacation afterwards, like a whole December after Thanksgiving. So yeah, that is a good part about it. Like you study hard and then you play hard. So, are you done, Samantha? Can I move to the next question? Okay, thank you. So let's move to our next question, which is the last discussion for our today's recitation. This is super interesting. So they ask how this is optically active and how the product is not optically active. So first of all, we need to understand what are the reagents. This is PBr3, Br2 water. So what are the reagents? This. What is the name of this reaction? It is Hell, Volhard, Zelinsky, halogenation. Okay. You guys can hear me, like see my handwriting, right? Okay. So now, what is the product? For PBr3, whenever is the reaction, from this, the first reaction is with PBr3, which will form a acyl bromide. Okay, retaining the stereochemistry. So whenever it is like here, there is hydrogen which is at the back. Here there is hydrogen which is at the back. Okay. Afterwards, there is a reaction, I would say, a keto-enol tautomerization. Okay. This is keto-enol tautomerization to get pH. So whenever there is enolate formation, there is this CH3 will go and form a straight line. It won't be like backward forward because it is becoming rigid because of the presence of this double bond. So at this step, whenever there is this Br2 addition, it can attack from the back or even it can attack from the front. Okay. So that's why the stereochemistry is, it's not optically active, basically. So the product would be oh, I'm sorry, that is CH3 and that is Br. There is no stereochemistry. Let me draw again. It just, I bolded it and it looked like stereochemistry. So it's OH and there is this Br. Okay? And it's not optically active. I would say inactive optically. Yeah. So that's the reason. Any questions? Online people, if you have questions, please type in. Did you guys understood what I said today? If yes, raise your hand because I know you guys won't speak anything. Okay. That's nice. Yeah, the point is, if you guys understand, then I feel good. If you don't understand, it's a wastage of time. So I hope you start studying for your exam. If you have any questions, you can anytime, always, can email Dr. Scott, or on Monday you can ask us. So yes, you will do great if you just follow what is told and what are the things. If you go through the mechanism, everything, that's the most part. So I want to give a tip for you guys. So whenever you have exam, so like until now, the questions were like MCQs and then IUPAC and then all big question, difficult question. So instead of going directly to the big questions, because it consumes your time a lot, because you try to think and everything. So instead, focus on your MCQ first, because those are very quick points. If you think for 2 minutes or 3 minutes, you will get the answer, but it's worth like 5 points, right? So you first go through all these MCQs, go through the structures, nomenclature. Those are very points gaining questions. So you make sure you do that. And then whatever the time is left, you first go through the fill in the blank question. Like in the scheme, you have fill in the blank. If you find it easy, if you don't find it easy, go through the mechanism. So just know what is your strength and what is your weakness. So whatever the questions are your weakness, do it at the end. Okay. So that would make you sure that you have a lot of marks. Because what happens is that when you start difficult question, you don't have much time to go through the easy stuff which you know. So yeah, do that. And also for reaction mechanism, always show arrows. Because even though you're writing everything wrong, but if you have structure 1, which is correct, 2, which is correct, and you have like 10 arrows, you get 10 points for 10 arrows, and 2 or 1 points for the structure. Even though you don't write the whole complete answer. Sometimes I would say 50% of students, or more than 50, they have written all the structures correct, but no arrows are mentioned. And that's why they lost point. So if you have arrows, structures, it's perfect. Yeah. But the arrows should be making sense. It should go from electron rich to electron poor. If those are wrong arrows, you won't get marks. So just do basic and you can, like easy points, yeah, and you can get good passing grades. Yeah. Yeah, that's just a tip for your exam. Yeah. And this is a week ahead, so you have time and you can improve. Yeah, wish you all the best. Yeah. Thank you, guys. Mhm. Thank you, guys. Mhm. Yes, we are done. And so I'm ending the meeting. Thanks, guys, for joining online.